Hello, welcome to another special Sudoku solve video. Today I have something else than Sudokuvania. I saw this and basically, okay, maybe let's just get into the puzzle and I'll explain my thoughts when I saw this. It's by Yttrio, who makes great puzzles in general, so I am excited to see what this one holds. Um, Draw a one cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. It's a normal loop rule, I guess. The loop acts as a German whisper line. Adjacent digits on the loop must have a difference of at least 5. Yeah. Cells with small numbers in the corner are on the loop. This number gives the sum of all loop cells, including itself, seen from that cell in all horizontal, vertical directions combined where non-loop cells block vision. Digits may repeat in a sum if allowed by other rules. Okay, so let's start with the easy thing. These are all on the loop. Then, where do you start? I was gonna say these cannot see each other, but they can, because this can just go up and that can go up, and that creates the two different totals. So I think it's going to have to start with this, right? Because, okay, from this cell, its sum can come from like these cells, right? But because of how this is structured, if the loop does this, right? Let's imagine this is the loop. Then it must go up, must go back, and then you only have 3 cells to make 34, and that is clearly not possible. So that is not loop. It never can be loop. I think same for that cell, because if it is loop, then it somehow wedges into the corner and that doesn't work. I think same for this cell, yes. Now this cell is a bit different. No, it isn't, because then at that point, this must be the loop, right? And then this can either go there, which creates a problem for the 33, or it can do this, but then you still only have 4 cells summing to 33, and that's not possible. So that's not true, so this must be loop. Now, this cell sees basically a straight line of cells. So 33, what's the minimum amount of digits I can make 33 with? 30 is 4, so it must be 5. A minimum 5 cells, so this has to be loop as well. Now these totals are different, right? Because this 34 sees every cell that is within that 33. So it must, right? If let's imagine the loop does like something like that. Now if this is the case, then this 34 and this 33 see the same cells, because this deviation is somewhere down here, so this counts, that counts, and there is no extra cell, so the loop must go there, so it cannot go there. And this must be a 1, because, you know, this sees the 33, the same as this, so the 1 difference must come from this cell. And now it cannot move here, so it must move up. And this cell can never be loop anymore, because then it would touch diagonally. So we know this is the case. Now it cannot take that cell, so we know this. And this must be 33, and I said that that's a minimum of 5 cells, so it must also take that one. And we know the polarity of the loop at this point. Well, the 33, it is not true that the minimum is 5 cells, I don't think, because that assumes that you use a lot of high digits. Yeah, that does. So, well, okay, so let's just look at it. 1, 2, 3, 4, that's not a 4. 1, 2, 3. So, and that is then Well, okay, could that ever be a 6? No, because then those two would have to be 1, those two would have to be 1, or those two. So that couldn't be a 6. So this is 7, 8, 9. So we know that that's 24 as a total. Oh, I moved the puzzle. Let's check if it's in frame. It is in frame. So that is 24 in total. With, let's imagine that's a 2-3 pair to max it out, right? I don't know if that is, well, that is possible, because that could be 7. You could have 8 and 9, or something along that line. So 2-3 is 5, so 24 plus 5 is 29, so we need at least another one, which is also 1, 2, or 3. Could be 4. Could be 4. That's not a 1. But now we have 5 as a minimum with 7, 8, 9. That could never be part of the loop now, because if it is, right? If it is, we run into a whisper problem, because that's a high digit, right? That would be a high digit, but it couldn't be 7, 8, and 9, so it would have to be a 6. And that would put 2 1s next to it somewhere. So that is not possible, that is not loop. So how do we reach the 33 then? Because 7, 8, 9 is 24. So these digits need to make 9. So the ways of making 9 is 1, 2, 6 in 3 digits. That's not possible. It is 1, 3, 5, and that's not possible. So it is 2, 3, 4. So there is no 1 within these. So that couldn't be a 7. That couldn't be a 7. That has to be the 7. And the 7 goes with a 2. Yes, that goes with a 2. And that one is a 3, and that one is a 4. That's a 9, and that's an 8. That's a lot of digits suddenly. I'm going to just 1, 2, 3, 4, where that's not a 1 and that's not a 4. That couldn't be a 4 either because of the 2 9s adjacent problem. So we know that's a 2 or a 3. This is a high digit, so it is, could be 6. 6, 8, 9. And that is 7, 8, or 9. So the next digit is a 9. But it could it do this? I don't see why it couldn't. But that, I don't know if that's possible. So what do I want to think about? This 31 clue now either takes one of those, right? Because it comes in here. So either it gets its sum from this, and if this is not possible to reach 31, then we have something. Because then it would have to move down as well. So let's see. That could be 9 plus 3 is 12. So we need 19 more. So could these 4 digits sum to 19? So we would have 2 and 4 as leftover digits, which is 6. And these would have to sum to 13. Which 6 and 7, but I'm not sure if any could be 6. Oh, but you could lower this digit, I guess. And then give yourself more space. And it would have to sum to 15. That does seem possible. From what I see now. So one of those is a 9. That is something. If it goes like that, right? And that's low, that is low. So that would have to be a 1. Well, okay, so what digits am I missing here? It is 1, 5 obviously, and 6. So that's not a 1, so one of those is a 1. Yeah. Okay. 15 is quite low. How many cells can that 15 see at most? Because, right, if you have too high... Okay, so one thing. Because this is how the whisper line moves, it always moves to orthogonal cells, creates this checkerboard pattern, right? Where everything on a checkerboard is a low digit, as I've highlighted it now, and on the inverse, it is all high digits. So we can kind of determine that this is a low digit and that is a high digit. So we know that this is 6, 7, 8, or 9. And we know that this is a low digit, right? Because it's 1, 2, 3, or 4. Could it be 4? It couldn't be 4. But I don't know how important that is, but I'm going to name it. Because if it's 4, right, you cannot have two 9s, so you would have to move it like this, but that couldn't be a 9, because one of those is 9. So you don't have two 9s to place around this 4, so it's not a 4. Now this is surrounded by two small digits, right, because it's either like that, or something. Okay, is there another, does this 15 see another high digit? I think that is the thing. Because, right, we could move it like this, and then that would be fine. It wouldn't see another high digit. But I think in any other, this doesn't seem possible to me. Because then that couldn't be a 6. That could be a 6 with double 1. But that would be a minimum of 7. That would have to be a 2. So we would have 1, 1, 1, 1, 6, which is 8. Plus 7 is already 15, and then that has a 2, so that's 17. So these don't see each other. So there's a wall somewhere between here. So either that's a wall or that's a wall. I'm going to highlight that for a second. Because, right, if that's wall, it must move into this 15, so it must move something like that. And now it sees 4 digits again. Is that possible? Is that ever possible that it sees another high digit? Because now this is 7, that could be 6, so we would have 13 again with double 1. That does seem possible. Okay, that's not what I hoped. Oh no, double 1 doesn't work, obviously, because if that's could that be, no. Oh, this isn't possible. This just isn't possible, because then that's 1, 2, that's 7, so that's already 10, and then that has to be a minimum of 5. That's not true. So that couldn't be wall. So that has to be wall. Now, right, I'm thinking it has to move in and out of this 15. It could be like this. That could be possible, but then we have 7, 1, and then that's a problem again. So that's not true. This is not the in. So, okay, I'm gonna draw a line. You have black as an option, you have green as an option, or, okay, so that doesn't overlap, obviously. So black wasn't true. This wasn't true. Oh no, it could be if we look at this scenario. Okay. Well, okay, so this isn't true. We know that because of the wall scenario. We know that that's not true. This isn't true because you cannot make another loop. You would have to loop back like that, and that's not possible. So this couldn't be the in, because that cannot be the out, that cannot be the out. So that does mean that this can never be snake, because then we run into that problem or this problem. So that's not snake. Those two have to be snake. Now, could that be snake? Then this is a minimum of 6 and 7, which is 13. Then we have 1 and 2, which is 16 in total. So that's not possible. So we know that those two are snake. We know that that's not. So how could we make that work? Could one of those be 4, for example? Because we know these are low, right? That's what I'm thinking. That can never be 4, because then we would have double 9. That couldn't be 6 at this point. So we have 7 with 1, 2, which is 10. That's not possible. 8 can go with 2 and 3, which is 5. Did I make a mistake then? Because 4, 9, oh no, 4, 9, 2 does work. No, 3, 9 is 12, then we would need another 3. That's not possible. So I think 4, 9, 2 is the only thing that works. Right, because, okay, so let's move through the options. Because if you have 7, you need 8 more, so that's not possible. If you have 8, you need 7 more, so that could be 3, 4, but that's not true. That doesn't work. If you have 9, you need 6 more. That could be 2, 4, and that does work, and that's the only way that that works. So 4, 2, 9, 9. That does work. So this is now, what is this, 7 or 8? Yes. That's not snake, we know that. And the next one is a small digit. We don't necessarily know which one. One of those is a 4. Interesting, so that's not a 2. Now, if that is a 3, we would have, oh, well, okay, so we know where the snake comes from, because it has to move into the cell and out of this cell. So this is the only way that is even possible. So we know that this has to loop around. So we know that that's a 1. We know that that's the 9, because it has to be the next digit on the snake. Now this is a 2 or 3. And then these are, well, okay, so we know that that's an 8, because that's a 3. And then the next digit also has to be an 8. And this is a 7 or a 7, just a 7 with a 2. And that's not a 1. That's wall, because the snake cannot move back on there. This can never be snake. Those can never be snake. These can never be snake. Then there's either one digit between here, which is not possible. That isn't possible, because if there would be a digit between, oh no, that could be just 1 or 2. That would then have to be a 1. Yes, that is possible. Okay, so 7, so the next digit is a 1, so one of those is a 1. And then we could have 8 again. Okay, yeah, one of those is an 8, but I'm not prepared to highlight that yet. That's 5, 6. So we have the 15 worked out, but now we need this. So we have 15, 23, 26, 27. So we need more. 27, now that's a 2 or 3. Wait, okay, so 16, 23, 24, 27. Oh no, that could be a 1. That I mislabeled that. That's a 1 or a 2. So this is 27. Am I saying that correctly? 11, 19, 27. So either 28 or 29, so it needs more. Basically, okay, so basically those two have to add up to 9. Could it be another one? Yes, with 6, no, 6, 1, 2 doesn't work. So if there is another one, we have a problem. Because, yeah, okay. Because you use one high digit, so it would have to be 6, 1, 2. So these add up to 27, so those have to add up to 9. So this plus this is 9, and there is not a next one. Now it moves here. So it could never be in that gap. This one could now not move here, so it has to move there. Now it couldn't move back on itself. That doesn't work, so it's like this. Now that could never be. So these have to sum to 9. So this is 6 or 7. So that's with a 7 and a 2. That's the only way I see that working. Because it can be 8 or 9. And with 6 you need a 3, and that doesn't work. So it's 7, 2. Then this is a small digit. It's 1 or 3. It's 1. And this is a high digit, which is 6 or 8. And that is a small digit, which is 1 or 2. Okay, that's a lot more knowledge, I think. 2, 3, so that's a 1. That does clear room for that to be a 6, but I don't know. You could. I don't think you could know. Well, you do know that one of those is a 9, I guess. So where now? This is 5, 6, and what's the last digit? It's a 7. So that's the only place 7 can go then. So that's not a 7, that's a 5. It's a 5, 6 pair. That is interesting. Okay. I don't know yet if that's any significance. 1, 2, I'm missing 3, 5, and 6. That's a 3, 5, 6. Oh, well, okay, so that's the only place. 3. That's fine. That all seems fine. Okay. If this is... Oh, well, that now couldn't be a 1, so that's a 1. That's a 4. This is where the snake has to move, so that's that. And that has to be a high digit, not 7 or 9. So it is 6 or 8. Couldn't be 6, because then that would have to be another 1, so that's an 8. Snake has to move up. That could now not be snake. Those couldn't be snake. This is now a small digit, so that is 2 or 3. This is, what am I missing? 3, 5, and 6. Seems to be some sort of theme. Could this 31 now ever be fully realized within these 4 digits? The answer is no, because the minimum you just need a lot more digits for 31. If you had any digit to your disposal, 4 digits would already be 30. So as a maximum, so that's not true. It doesn't move down; it moves to the side. Because right, if it moves down 1 and then moves to the side, it doesn't see it. So you just don't have the space for that. So that's a wall. That is wall. This now is a high digit that is not 7 or 9, so it is 6 or 8. It is not 6 because then it would need 1, so we know that that's 8. So we know that that is a 9. So it has 17. So we need 4 makes 21, so we need 14 more. With 14 more, that's quite a bit. My question is, right, within these 4 digits, like, let's imagine it doesn't take that one. If it doesn't, right, is that possible? Because then these would have to sum to 22, and the 2 high digits we can use is 17, and these would have to sum to 5. That does seem possible. But it also always 17 plus at most 3 makes 20. So that cannot be 11, so it needs to take 17 plus 3 makes 20, so it needs to take at least those. That is another high digit. So it's not 7 or 8. It couldn't be 6 because 6 would need 2 1s next to it. So that we know that that's a 9. This is a high digit, which is 2 or 3. So if that is a low digit, it's a 4, and that's a problem. So that's not true. Also, we know that 17, 26, so we need 5 more, and that's our 5. So we know that that's the arrangement. Now this can all not be snake, so the snake has to move down. Those can now not be snake. This creates a gap, and that doesn't work. 2 with 1, 3 or 4. I feel like I have to do more Sudoku. That I'm just not doing. That's now a 6. So we know that that's a 9. So that's a 5. That's a 6. That's 5, 5, and 6, 5. Neither of those is now 5, so we have a 3, 6. Could that be a 4? No, because then either that's a 9 or that's a 9, and both don't work. Right, so what am I missing in this row? It is 4, 4, 5, and 6. So we know that that's the 4. Know that those are the 5 and the 6. So we know that that's the 6. That's the 5. This is actually going fairly well. I really like the flow of this puzzle. It's pretty quick, and I don't think it's that hard in general, but very, very structured, if that makes sense. This is either... Right, if this is a high digit, so either one of those is a high digit, that's what I'm looking at. Yeah, that could be a 6 or an 8, and that could be a 7 or a 9. But both seem to work. Is there any digit that cannot be... Well, okay, maybe more Sudoku, 4, so one of those is a 4. One, no, 3, right? So one of those is a 3. So none of those can be a 3. So one of those two is a 3. So 3 is down here. Oh, that 8 makes that a 6. That a 1. Now 6 cannot be in one of those. So 6 is in one of those. So 6 is there. 4 is there. What am I missing? It is 1. So obviously 2 and 3. And then one more digit. 1, 2, 3, 4, 5, 6. 1, 2, 3, and 7. That's not a 2. Okay. That didn't do as much as I thought it would. Missing 2 digits in this column. It is 1, 2, 3. I'm missing 4, and then 5, 6, 7, 8, 4, 9. Okay. 9, one of those is a 9. Maybe it's from here, from this perspective. What is the next high digit? That could be a 6. No, wait. That would have to be a 7 then. If this is the next high digit. That would mean that that's a 1, and that would mean that that's a 2. But that does... I don't see a problem, because that could be 9 and that could be 3, and then we're fine. Okay. What digits am I missing here? 1, 2, 3. 3 and 8? Yes. What digits am I missing? I'm just gonna label everything and see what that brings me. 1, 2, 3, 4, 5, and 6. 1, 5, and 6. That's the normal digits to be missing, I think. Then I'm missing 2, 4, and 7. Okay, so we know that that's not 7. We know that that's not 1 or 6. So, so we know that that's 5. So none of those are 5. 2 or 4. No, I think that's it. I was hoping Sudoku would bail me out, but it didn't. Okay. If this is a small digit, it cannot be a 4, so it would have to be a 1. Which will make that a 3. And would mean that those two are connected. So there would be something between, which would have to be an 8. And that's not possible. Oh, maybe that's a way of seeing it. Well, okay, so what scenario did I say that that would have to be 1? If this is a small digit, it's not 2 or 3. Couldn't be 4 because there cannot be 2 9s next to it, so it would have to be a 1, which will make that a 3. And the loop couldn't loop like this because, you know, that would break it, so that would have to be the case. That's now a 3, right? That's a 9, so the next digit would have to be an 8, and it cannot be. So this cannot be snake. So that cannot be snake, so that is snake. Oh, so that is snake, so that is snake. Now that's a small digit, so it's not a 9, so that's a 9. That's wrong. I'm sorry. That's the different way around. That's a 9. That's not, no. That's not a 9. This is now 2 or 3 because they cannot be 1 or 4. And the next one is a big digit again. But that could be, that couldn't be 7, 8, or 9, and it couldn't be a 6. So that's not it. So it's this one. With, in my eyes, only a 7. Yeah, because it's not 6, 8, or 9. Okay, so that's a 1, that's a 2, that's a 3. That's beautiful. Okay. So now it's just Sudoku, I guess. 2 isn't there anymore. 2 is now in one of those. So not there as well, so it's there. So what am I missing here? It is at least a 4. 1, 2, 3, 4, 5, 6, 7, and 8. At this point, now that's an 8. Now that is an 8. That is a 3, so that's not a 3 anymore. There's 3 in the corner as well. So one of those two is a 3, so that's a 6, and that is the 3. Now 6s. Ooh, not quite. What am I missing? 5 and 6. It's kind of logical that you're missing 4, 5, and 6 a lot because those are hard to place on a whisper. So that does make sense. 4 in this box, it can only be there. So that's now another 2 or 7. Okay, where can you place 7 in this top row? Couldn't be there because of this 7, so that's a 7. So we know that that's a 2, so that we know that that's a 3, 2, 3. Then we're missing 1, 2, 3, 4, and we're missing 5. That's now a 3 because of my pencil marks. That 9 places the 9, the 4, and the 7. So what digit am I missing here? It is 1, 2, 3, 4, 5, 6, 7. It is 8. And now I'm missing 2. 1, 2, 3, 4, 5. 5 and 6. 6 and 1. And 1 and 7. And that's the puzzle. Kind of a short one. I liked it though. It's really, really sweet. The way it flows is beautiful. Thank you for watching and have a nice day. Bye bye.